Hi everybody, and welcome to our last video on C++ material. So in this last video I was torn as to what to show you because we only have one day left, and what can you really do in a day? Like, it'd be nice if we could finish the course by talking about how to program Halo 6 or something, right? But with one day you can't do very much. So what I want to do is give you a glimpse into the power that C++ has, and I can't really show you why what we're going to do is super powerful, because again, we only have a day. So if I really had the opportunity to show you how this stuff is used, it might take 2 weeks or something of class time to really unlock the power of what we are doing. But I want to just give you a glimpse into one of the reasons why C++ is so powerful. So the last topic we are going to discuss is it's called a class. So we're going to talk about defining classes and what they are used for. And let me just state up front that when I taught this course last time, the students found the concept of classes to be the most difficult in the course. They thought classes were more difficult than functions, than loops, than arrays, whatever. So if I really wanted you to get comfortable with classes, we would spend probably 4 or 5 class days on them. So 4 or 5 times longer than we have. So let me just tell you up front that on an exam or on a homework or something, you will not be coding with these. Okay, I'm not going to ask you to code anything. What I am going to ask you about are global questions like, what is this class doing? Why does it exist? Why do classes exist? What do classes do for you? So global questions like this that don't have anything to do with the code itself are the kinds of questions you will answer. So classes are difficult and they take getting used to, but you won't have to get used to coding them, right? We only have one day, so I can't expect you to do much with them. But in this video, I'm just going to show you a couple of them, show you how they work, and I'll give you some sample questions that I might ask you on an exam. None of those questions involve you coding anything. Okay, so let's just jump right into what a class is. To start with, let me just point out that we've been dealing with several different data types throughout this course. We have integers, longs, which are just bigger integers. We have floats and doubles for decimals. We have Boolean variables for true and false values, and strings and characters. And that's it. We haven't dealt with any other data type. And it's worth pointing out that some kinds of variables don't really fit nicely into any of these 7 categories. Whenever you want to keep track of something, you have to create a storage space for it, and you only have 7 options for the kind of storage space that you're going to create. You either create a whole number or a decimal, and now we've already covered 4 of our data types, right? Or maybe what you want to store is a true-false. Otherwise, you basically have a string. That's it. So when I say some kinds of variables don't fit, this should be fit nicely into one of these 7 categories, I mean, some really should be most if you're taking a global view. There are just so many kinds of things that you want to create storage space for that don't really fit nicely into these categories. And I'm going to show you a couple of examples. So think about a playing card, an ace of hearts, a jack of clubs, whatever. How would you store such a thing? You want the computer to keep track of playing cards. What kind of variables are you going to create to store playing cards? I suppose you could store it as an integer. You could store, how would you do that? You would store it as a number between 1 and 52, I suppose, right? And then just keep track of which number corresponds to which card. So maybe a 1 is an ace of clubs, and a 2 is a 2 of clubs. All the way up to a 13 is a king of clubs, and then a 14 maybe is an ace of diamonds. You could do something like that. But that's kind of unnatural. You always have to translate back and forth between the number between 1 and 52 and the card you're talking about. Or you could save everything as a string. You could literally have ace of clubs as a string, right? So, you could have int card equals 7, and by that you mean 7 of clubs or whatever. Or you can have a string card equals, 7 of clubs, ace of clubs. But neither of these storage spaces is ideal, because if you think about it, what is a card? What makes up a card? A card has two components, doesn't it? It has a suit and it has a number or a value, however you want to say that. A card is a something of something. So there are two components that make up a card. And none of these variable types let you keep track of two components. I suppose that you could store the two components as a vector of length 2 if you wanted to, but even that's kind of unnatural. Yeah, so if you're going to have a program that deals with cards, wouldn't it be nice to have a data type that's not one of these 7? A data type that is specifically built to deal with cards. Wouldn't that be nice? Wouldn't it be nice to have declarations like this? Card, my card. So you are literally telling the computer, I want you to create a storage space of type card. And you want the computer to know what you mean by that. You want the computer to know, oh, he's going to create a variable that has two components, and one component stands for the card value, and the other component stands for the card suit. Wouldn't that be nice? And then you could give your card a name, right? So my card. So wouldn't it be nice if you could tell the compiler this? I'm going to create a card, and it's going to be called my card. You might not think this is nice, but I consider this nice. Wouldn't it be nice to have a data type specifically for what you're dealing with? You're not really dealing with an integer. You have to make a translation to do that, And furthermore, think about the string data type. The string has all sorts of functions designed just for it, doesn't it? Like the erase function, like string.erase, and the length function, string.length, string.substring, string.find. All of these functions are built in, and they are designed specifically for use with strings. So suppose you had this card data type, this data type that's built to deal with cards. Wouldn't it be nice if you could build your own functions that are designed specifically to be used for cards? Think about a dealing function, right? Or a function that displays a card, and it displays the suit and the card number. Things like this. Wouldn't that be nice? Okay. So what I'm going to do now is I'm going to show you, I'm going to plop the code in front of you. So you're not going to understand much at first, but what I'm going to plop down in front of you is all of this. I'm going to show you the code that you could use to build your own data type that's built to declare card variables. And that data type will have certain functions built into it specifically to deal with cards. So again, this is not going to make much sense when I just throw this in front of you, but that's okay. You just have to roll with it. Where's my... Okay, there it is. So just like this using namespace standard command right here, right? Just how you sort of like acknowledge that that exists, but you don't know what it does. I'm going to show you a bunch of stuff now, and I want you to do the same thing. Let me just talk you through this. So you see this class card right here? You are declaring a class called card, and class, for us anyway, will be synonymous with data type. So what you're doing is you're telling the computer, I'm going to create my own data type called card so that I can declare card variables. And let's just ignore this stuff for a second. Let me scroll all the way down. Okay, so let me just say one thing first. Data types are divided into a public and private, sections. Okay, so there's like a public section of your data type and a private section. That distinction is totally irrelevant for this video, so I have to have both of those words there or my code won't compile. So, private would be for things like social security numbers. Private just means that it's harder for the code to access if you make things private. You have to access them entirely within this class code itself. But in any case, that is not important for us. So all the way down here, just above private, here is where I declare the components of this data type. I'm telling the computer, look, I'm going to create something called card. And whenever I declare a card variable, that variable will have two components, a suit and a number. And I'm going to declare them as integers because I'm going to keep track of the suit as a number between 1 and 4. And I'm going to keep track of the card number by using a number between 1 and 13. So if your suit is 1, you're talking about a club, suit is 2 diamonds, suit is 3 hearts, and then suit is 4 will be spades. And then the number means what you think it means. A 1 is an ace, a 2 is a 2, and so on. A 13 is a king. Okay, so I've declared a data type called card. A card consists of 2 components, both of which I'm keeping track of as integers. So once you tell the computer this, you can now go down to main and write things like this. Card, my card. And there you go. You've now created a storage space, and the computer knows that that storage space is going to be of type card. So the computer knows that this particular storage space will have 2 components, a suit and a number. Isn't that nice? You know, I can't really overemphasize how important this is, that you can build your own data type of any kind you want. You know, this is sort of a very small toy example here of dealing with cards. And I'm going to show you a more advanced example in a second, but just think about what this allows you to do. You can build your own data types now if you're comfortable with classes. Okay, that's extremely powerful. And now let me come back up here and just tell you what some of this stuff does. Set card, since I'm declaring it inside of my new data type, it becomes a function that's designed specifically for the card data type. So it's just like the dot substring for strings. Okay, the set card function literally deals only with cards. So I can build my own like dot substring, dot erase, dot find. I can build those kinds of functions for my card data type. And I do it inside of this data type declaration here. So all of this stuff, I'm building my data type. So I'm telling the computer what my data type consists of. Oh, 2 components, a suit, and a number. And I'm also going to tell it functions that are used for it. So this first function just lets me feed in 2 values to tell the computer what my card is. This second function here is called display card, and it does what you think it should. It tells you what the card is. So notice it says if card number is 1, well, the number being 1 means that the card is an ace. You know, if card number is between 2 and 10, then the number is literally the card number, right? A 3 is a 3. And then when you deal with 11, you're talking about a jack, 12 is a queen, 13 is a king, and then we already discussed the suits, right? If the suit is 1, you're going to say clubs, etc. Okay, so now I can come down here and say card my card, and now I'm going to set my card. So I use the dot command to call on these things, just like dot substring, dot erase, you know, whatever. And suppose I feed in, I have to remember how this goes. So X is the card number and Y is the suit. So I actually feed these in the opposite order than you might expect. But anyway, so let's say I want the, you know, the jack of clubs. So a jack is 11 and a clubs is 1. So now I can say, hey computer, can you please display this? So my card.display card, and it will do it for you. And let me just comment out all of this stuff after this. So let me just run this for you and show you that it does what it's supposed to do. Jack of clubs, okay? So again, this line of code right here lets you declare a variable of type card. This line of code right here lets you initialize or set the card value, you know, to a jack of clubs, and then this line of code actually displays that card for you. Notice if I change this 11 to a 12, this 1 to a 3, it should change this to a queen of hearts. Okay. So now let me get rid of this and uncomment what I had here. Once you have a data type, you know, like int or string or whatever, you can create lists of those things. Okay, so a vector is a list, right? So you can now declare vectors of type card. Why would you want to do that? Well, because a hand of cards is simply a list of cards, isn't it? You know, a poker hand of 5 cards, that's just a list of cards. So if you want to have like a poker program, right, It seems like what you should do is build a data type of type card so that you can have card variables, and then deal with vectors of length 5 for a 5-card poker hand. Or in this case, I've declared a vector of length 2 because I'm thinking about blackjack, where your hand has length 2 at the beginning anyway. If you start hitting, right, you get more cards in your hand. But at the very least, understand what this is saying. This is saying I've now created a list of 2 cards, and I've called it my hand. So my hand right now consists of 2 cards. The 2 cards don't have any value yet, so think of it as like being dealt the 2 cards face down or something, right? You don't know what they are. So let me just deal the hand, right? Deal blackjack hand. Notice I can build other functions too to deal with this sort of thing. So this is a void function. It doesn't return anything. But notice what I hand it, or what I give it as a parameter. I give it a card vector. So I can give it a list of cards. And that vector has 2 items, right? Item at position 0 and item at position 1. So I tell it, hey man, set up the first card, right? My card at position 0. And choose a, oops, sorry, these are in the wrong order. The card number comes first, and the suit comes second. So hey, randomly choose a card number and then randomly choose a suit, right? That's how a dealing works, I suppose. And same thing for this next guy. I had these guys backwards. So let me just fix that. So okay, deal me the first card. That's all this is saying, right? The card that I'm holding in position 0, set that card to a random card number and a random suit. And then do the same thing for the next card. Except you don't want the first card to be the same as the 0th card, right? Once you've dealt this first card here, you don't want to deal the same card the next time. So I had this loop down here that basically says, hey man, if the suit and the number of my 0th card equals the suit and the number of my first card, then please choose again. And so again, this is backwards, so let me just fix this. Okay, so this will literally deal you 2 cards. One card is right here. This is the 0th position in your hand, your first card, I guess. And here's the 1 position in your hand, which is your second card. And this function will literally just randomly fill those 2 positions and make sure that the first position is not the same as the 0th position. Okay, so let's come back up here to main. I've created a vector of size 2 where each entry is a card. And then I say, please deal the hand. I pass the hand by reference so that all of this down here is remembered. And then I have the computer say what my hand is. And then I print it. So I have another function down here that simply prints all your cards. So however many cards you have, that's hand.size, this just marches through, and for card 0, card 1, card 2, etc., it just displays them using that display function I built. So let's just run this and see what it does. Your blackjack hand is 7 of diamonds, 4 of spades. Nice, right? So you got an 11 right now. You hit that real hard, right? The odds are good of you getting something of value 10. So I haven't built a blackjack program, of course, or I would tell it to hit right here. But anyway, just notice what happened, right? So I built my hand, and that's empty right now. Then I dealt it. So these 2 values are actually assigned right here at this step in the code. And then I just say your hand is, and I print those 2 values. Okay, so again, this is just extremely powerful. I really cannot overestimate how useful this is in practice. Not for us because we're essentially done now. But notice just how natural this is. If you're going to build a card playing program, it seems natural to just build a data type of type card. That's what you're dealing with all the time. And then build a bunch of functions that deal with cards, right? That handle cards. So in plain English, this main here is actually pretty easy to read, isn't it? If you know what's happening. I've created a list of cards of size 2, which is a blackjack hand. I then deal that hand, and then I say what the hand is. Right? So you can just read this in English, and you kind of see what's going on. Okay, let me now go back to my notes here. Okay, so here's a response you might have to what I just did. Cards are easy to deal with, aren't they? I'm just going to store them as numbers between 1 and 52 and just remember my translation. So 1 is an ace of clubs and so on. That class thing that you set up is needlessly overcomplicated, isn't it, for what I'm trying to do? I don't need to build a new data type just to declare variables of type card. Isn't that overkill, you know? Isn't this just overly complicating things? And hopefully I've already given a partial response. I mean, not really. It's just so much more natural to deal with a data type of type card if you're going to build a big program that uses cards all the time. So the program I built didn't do much, but imagine building a program that lets users play blackjack, poker, cribbage, go fish, you know, I don't know, all the card games, right? It just is so much more natural in the code to have all of your cards stored as cards. It makes things way more readable. Everything is streamlined. You know, you've built everything for that specific purpose. It's so much nicer. But point taken. You know, let's now move on to a next example. Imagine you own a business, or you're building a database for a business. You need to keep track of employee data. So for this play example, let's say that there's not much you have to keep track of, but you can imagine this list being very long, right? Their name, their social security number, maybe their marital status, which might be a Boolean thing, like, you know, true if they're married, false if they're single, and maybe their home address, maybe their age, maybe whatever, you know, hair color, I don't know. The things that companies keep track of, years that worked at the company, you know, all this sorts of things. So anyway, imagine you want to keep track of employee data. You could keep track of all this with strings if you wanted to, right? You could have something like this. String employee1 is. This employee is me. His social security number is this, which is fake before you all try to steal my identity, right? This is not my social security number. It's simply my email password, okay? I'm not an idiot to give you my real social security number. Okay, so my social security number is this, and my salary is $1 million. Okay, so, not terribly realistic. My salary is, divide this by a significantly large number, you will target my salary. But anyway, you could keep track of data with a single string, okay? But notice how inelegant this is. Suppose that you don't care about employee one's social security number, you only care about their salary. How are you supposed to dig through the string and get the salary out? You know, imagine you have 1,000 employees. That means there are 1,000 different strings floating around, all of different length because people's names have different length, their salaries have different length. You know, how would you separate the salaries out from everything else? Especially if this list of stuff you keep track of is long, right? Especially if you want to keep track of maybe 30 different things. Now you got to separate these strings out, you know, parse through all of these strings just to pick off the salary. How obnoxious. Or you just want to figure out what their social security number is. Now you got to search through the string for that, you know, ridiculous. Right, so that's clunky, inefficient, right? Right, suppose you're trying to keep track of a bunch of things, not 5, but maybe 50 different things, their home address, you know. How do you take a single string and separate out all of these things in an efficient manner? Well, why even bother? You know, why even deal with strings like this to begin with? That just seems so inefficient. Why would you do that? So let's step back from this, right? Let's put this on the back burner for a second and just ask, well, from the computer's perspective, what is an employee? You know, what makes up an employee? And in this toy example, an employee has 5 components. Their first name, their middle name, their last name. You know, you maybe don't need to keep track of these 3 things separately, but I will. You know, I'll separate their name into the 3 components, their social security number, and their salary. So an employee, from the computer's perspective, is these 5 things. That's what an employee is. Okay, well fine. So then it would be nice to declare variables of that type of thing that has those 5 components built into it. So you'd like in your code to declare something like this, employee and then employee 1, whoever, right? And you would like the computer to know what this means. And what this means is you're creating a storage space for something that has 5 components. And what are those components? The 3 names, the social security number, and the salary. You know, wouldn't that be nice? Wouldn't that make everything way more streamlined and way more logical, than just trying to have strings all over the place that you have to keep track of? So all of that being said, let me now go to my code and put that in here. Okay, so this now, I have a data type that I'm calling employee because it's built to track employee data. And then I'm going to scroll down here again to right here at the end of my data type declaration. For whatever reason, that's where these variables go. I don't know why. But here I tell the computer what the 5 components are. There are 3 strings, for first name, middle name, and last name. There's a social security number, which I'll store as a long because it's a big number, right? Hundreds of millions. And there's a salary, which presumably can have decimal points, right? So I'll declare it as a float. So again, the big picture of this is I'm creating a data type of type employee. Well, what is an employee? An employee, from the computer perspective, is these 5 things. An employee is made up of a first name, middle name, last name, social security number, and a salary. So I've told the computer that that's what an employee is. And now, just like before, I can have functions like, well, let's set their info up. So let's feed in their first name, middle name, last name, and feed in their social security number and their salary. And then we can have the computer display that information if we want to. So let's say that get rid of that. Let's say that you're a small company. You only have 5 employees, So now let's create a list of 5 employees. Let's just say the first employee is me. Here's my name, here's my email password, and here's my salary of $1 million. So I set all that up, and now the computer knows, oh, of these 5 employees, the first employee has this data, has this name, this social security number, this salary. So now when I tell the computer to display the 0th employee, the employee in the first position, it will do so. And let's just run this and see. So my name is this, and notice in my function here, when I tell it how to display things, I say name, and then I show the last name first with a comma, and then a space in between first and middle, and then social security number, whatever it is, salary, whatever that is, So it does that for me. Anyway, so don't get lost in the code here. Just focus on the big picture. I have now built a new data type that the computer understands. So I can now write things like employee, employee 1, just like I wanted to. And now I can store the employee's data as components of this guy. Okay, so again, it's hard to show you why this is so powerful in general, because we are now out of C++ time, aren't we? All we have left now is to review for your exam, you turn in your group projects, and then we move on to HTML, which is totally different. Okay, you're not going to see things like this in HTML. But I just wanted to give you a flavor of what you would see in a more advanced C++ course or computer programming course. This kind of thing here is called an object. So if you ever hear the phrase object-oriented programming, C++ is such a language. It allows you to build these things on your own. If you don't want to deal with the built-in data types. So you want to keep track of things, and you think to yourself, what I'm trying to keep track of isn't really a single string, isn't really a single number, and so on. What I'm really trying to keep track of is 5 different things, and some are strings, some are whole numbers, some are decimals. So I want to just declare a single variable that keeps track of these 5 components separately. You can do that. You can build your own data type that will do whatever you want it to do. You can build your own built-in functions that do whatever you want them to do. This is a very low-level example. I've only built 2 built-in functions here. But you can imagine building hundreds of functions for all sorts of specialized tasks, And here, as soon as you decide, well, maybe I want to keep track of more data. I don't just care about these 5 things. I care about, int number of years with company. Maybe I care about that. Maybe I care about their age. All sorts of things. If you want to now keep track of more components, that's not a big deal. You just add those components to this data type you built, and now you have to tweak all of these functions to deal with all these components, but that's all done within the data type itself. Once you move out of the data type, once you move back into main, the stuff doesn't really change very much. You just have to remember you've added more components. So these data types are flexible to deal with whatever you want them to deal with. They can keep track of anything. Okay, so let me just close by saying when I taught this course last time, the students did not like classes. Mainly because they take getting used to and, well, why else? The coding itself is kind of complicated because you have these built-in functions here, but you can also have normal functions outside of the data type, just like I did with the card class, which, let me just bring that back up. Here it is. So I don't need to put it in my compiler. Let me just show you. So there are these functions inside the data type itself, and then there are normal functions outside the data type. Like this deal was not part of the data type. It was outside of the data type. And you hand it vectors of card data type. So they just take a lot of getting used to if you really want to code with them. They are just difficult to deal with in practice when you get your hands dirty. Okay, but they're extremely powerful. And I'm not an actual programmer, but I imagine that most programming wouldn't run without some kind of objects like these, right? This just streamlines things so much. It gives you so much power. It's just really hard to imagine some really sophisticated programs running without this sort of thing. Okay, so now let me really close this video by saying you will not deal with code like this yourself. I'm not going to say to you, build me a class that does this. Okay, I'm not going to do that. I did do that for my previous course, okay, but we spent 4 or 5 days on this stuff. What I'm going to do is I'm going to give you a class and just ask you questions about it, like for this class right here, right? Let's just keep this up. I could ask you, from the computer's perspective, what is an employee? Okay, that's sort of an open-ended question, but you would just scroll down here, look at these component variables, and say, oh, from the computer's perspective, an employee is their 3 names, and then these 4 numeric things, their SSN, their salary, how long they've been with the company, and their age. So just global questions like that. Like, what is this thing doing? What is this employee data type? What's it keeping track of? Why would somebody want to create a data type like this? And to that you would answer, well, because an employee consists of 7 different things, so it's nice to separate those 7 things out and build an object that consists of those 7 things. So really global questions like this is what you will have to answer. Okay, so don't worry about the nitty-gritty of the code here at all. On your exam, I might just ask you something like, why are classes important? And you would just say, because they let you create your own data types, which gives you lots of power. Okay? So those are the kinds of questions you will answer. So that's all I have to say about classes, and we are now done with C++.